last time? Okay, so we're on question 4. Please read the question carefully. It's the same combination of more than one, linear combination of two or more variables. So apparently there are 4 random variables involved here: u, v, w and x. And we have the average times of 4 stages of the journey. So expected value of u is 1.1. Expected value of v is expected value of u is 4.7. Expected value of v is 5.6. Expected value of w is 21.6. And for x it's 3.7. And the variance is also mentioned. Expected time and standard deviation of the total journey. So expected time, the total journey, okay, let's say we call the total journey j, and j is basically u plus v plus w plus x. So I'm calling the total journey time as a random variable j. So it's a sum of all the 4 stages. So expected value of j would then be expected value of u plus v plus w plus x. And I guess that will be 4.7 plus 5.6 plus 21.6 plus 3.7. 35.6. 35.6 minutes is the expected time for the entire journey. Okay, by the way, these values 1.1, 1.2, 3.1, please be careful, these are standard deviations, not variances. These are not variances, these are standard deviations. So when they are asking for the overall standard deviation, the summation formula that we have is only for variances, not for standard deviations. So you will have to first convert them to individual variances, then add them up, and then convert it back to the standard deviation. So you just can't add the standard deviation and get the total standard deviation like that. So the variance of j would be variance of u plus v plus w plus x, and that would be actually 1.1 squared plus 1.2 squared, because these are standard deviations, so square of the standard deviation is the variance. 1.2 square plus 3.1 square plus 0.8 square. That will give us the variance overall, which is how much? 12.9. Okay, so standard deviation would be root of 12.9, which is 3.59. The question is asked for the standard deviation. So please be careful. Don't take the linear combination of the standard deviations. You can take the linear combination of the variances. And then once you get the overall variance, then take the square root and get the overall standard deviation. Are you all okay here? There are some boxes that have been produced by a machine, and we have the average length and the variance of the length, and we have the mean of the width and the variance of the width. and we are interested in finding out the expected value of the variance of the perimeter of the box. Now we know that the perimeter of the box would be twice the length plus twice the breadth. Right? That's how you calculate the perimeter. So, if you are interested in finding out the expected value for the perimeter, that is equivalent to finding the expected value for 2L plus 2B, which would turn out to be twice the expected value of L plus twice the expected value of L. Do we agree on this? And I think we have these values with us. Expected value for the length is 26, expected value for the breadth is 14. So 2 times 26 plus 2 times 14. How much is it?
80.
80. 80. So the expected value for the perimeter of any box is 80 centimeters. Can you get the variance as well? So variance of P would be equivalent to finding variance of 2L plus 2B. But for the variance,
Square.
the 2 comes out as a square. So it will turn out to be 2 square variance of L plus 2 square variance of B. And that would be 4 times 4 plus 4 times 1. 20. That's not 48 units. 20. Are we all okay till here? The difference between the length and the width. So the random variable over here is, let's say the random variable x is equal to L minus B. The difference between the length and the width. So I'm just calling it a new random variable x. So expected value of x is actually expected value of L minus B, which is expected value of L plus expected value of minus B, which turns out to be expected value of L plus, minus expected value of B. So I guess expected value of L is how much? 26 and B is 14. The answer is 2.
सर मैंने वेरिएंस क्यों निकाला? पहले निकाला।
क्यों निकाला? तुमने क्वेश्चन में पूछा है। अब पूछना तो मना तो नहीं कर सकते। हाँ ये लग गया। क्या नहीं निकाला? अच्छा ही लगा। Okay. Difference between length and width. Now what about the variance? Variance of x is variance of L minus B, which will be variance of length plus variance of minus B, which in turn turns out to be variance of length plus variance of B. The minus 1 comes out as a minus 1 square. So for the variance it's always a plus. So variance of length is how much? 4 I guess, and variance of B was 1 I guess. 5. Everyone's okay till here? Any questions? Now, in order to find the expected value of x and the variance of x, you need to know the expected value of h and s, and you need to know the variance of h and s, which is not given in the question. So you need to first calculate it. So let's find out the expected value of the number of heads, that is h. So we make a table, make a probability distribution first, and then we calculate the expected value of h. So probability of h. So number of heads when you throw a coin. When you throw a coin, how many heads? What are the possible values of the number of heads that you can get? 0 or 0 or 1. What is the probability of getting no head? And 1 head. Okay, when you throw a dice, what is the probability? Okay, what numbers? What scores can we get? 1, 2, 3, 4, 5 and 6. These are all the possible scores. So what is the probability of any number coming by 1 by 6 throughout? So expected value of h would be multiply each value with its own probability, right? And that would be 0 times half plus 1 times half, right? And for this one, expected value of s, we will multiply each value with its own probability, add them up. 1 times 1 by 6 plus 2 times 1 by 6 and so on. I believe your answer will come out 3. Check. No, 3.5. Check. Your answer should come out 3.5. Similarly, can we calculate the variance as well? So for the variance, I think we need to first get E of h square, right? Which is the same in this case, because h square is also 0 and 1. So I get E of h square should also be a half. But what about E of s square? So we take the square of each value, 1, 4, 9, 16, 25, 26, and recalculate the expected value with these new values, 1, 4, 9, 16, 25, 26. Multiply each value with its own probability. That's 1 times 1 by 6 plus 4 times 1 by 6 plus 9 times 1 by 6 and so on. Check what value are we getting. 15? Okay. E of 8s square is coming out to be 15. So clearly variance of h is E of 8 square minus E of h whole square, and that should be half minus 1 by 4. The answer is 1 by 4. 15. This is not right. How much is this? 51.
15.1667.
Okay, can you give me the exact value? The fraction?
91.6.
15 1 by 6. Okay. ठीक है. Let's go with exact value. Okay, so I got the variance for H. Now let's get the variance for S. That would be 15/1/6. That's 91/6 minus 3.5 squared. Can you give me the exact value here as well, because we're using it later, so we'd rather 35/12. I hope everyone's with me. Is everyone getting 35/12? Okay. So now I think we can calculate the expected value and the variance for 2h minus 6s. So 2h minus 6s. So expected value of 2h minus 6s would be equivalent to 2 times expected value of h minus 6 times expected value of s, right? And I guess that would be 2 times half minus 6 times 3.5. It's a negative value. It's minus 20.5. Exactly.
Minus 20.
20 minus 20.5.
Minus 20. Exactly. Minus 20.
Minus 20 exactly. Okay. Okay, what about the variance? Variance of 2h minus 6s would be variance of 2h plus variance of minus 6s, which would turn out to be 4 times variance of h plus 36 times variance of s. Are we all getting 106? There's no way the variance comes down. There's no way the variance comes down. Add to the settings. Adding. There's no way to minus somewhere derivation adding. In fact, it's increasing the spread. Almost good. Individual variance more variables involved in your analysis. So what most time we do is minimize individual variables. That's the best we can do. Are we all good till here? Any questions? Alright. Okay, guys, this is just hear me out on this. Now, up till now, we are dealing with independent random variables, like length was independent of the breadth of the box, and whatever you were getting on the coin was independent of whatever you were getting on the dice. And that journey that the guy took, there were 4 stages to the journey. First stage was independent of the stage. But that's not always the case. Sometimes there is a situation and there are multiple observations taken from the same scenario. Like, I will read the question to understand this. Let's take this one. Okay, now they are asking for the expectation in the variance of the number of heads obtained when 6 coins are tossed. Okay, so this is a case where I would look at it as 6 instances coming from the same experiment. The experiment is flipping a coin and noting whether you got a head or a tail. You've done that 6 times. So basically you are observing, getting 6 observations from the same random variable. See, every time I flip a coin, okay, let's say I flip a coin once. What is the expected number of heads? I think we just calculated earlier on. It was either 0 or 1 and the probability was half for both of them. So the expected value that we calculated, the expected value came out to be half. Now, do you think if I flip a coin and I say, okay, what am I expecting? So I'm expecting half a head. Over 1 flip. Over 2 flips means one head over 2 flips. Right? That's how the probability half comes out. But does that mean if I keep the coin and I go away and then I come back and I flip the coin twice again, so would the expectation change? No. So basically the experiment is the same. You are just taking 6 observations from the same experiment. Right? That is why I will not call it X, Y, Z. Like if so there were how many? 6 coins. So each coin is giving you each coin is providing you with the same expectation for the number of heads. Whether you take 8 coins or 10 coins, the expectation you have from each coin to give you a head is still half.